Okay, rational zeros theorem. So this is a theorem that's going to help us find zeros when looking at just like any polynomial. So recall that polynomial functions of degree n can have at most n real zeros. So that means if we have a degree like x cubed plus x squared minus x plus 4, that could have 3 zeros because of this. If that was like x to the 7th, it could be 7 zeros. X to the 11th would be 11 zeros, and so on. Okay? So real zeros can be rational or they can be irrational. And remember, a rational number is a number that can be written as a fraction. So 1/2, 4 can be written as a fraction because that's just the same as 4 over 1, 3/4. Irrational numbers are numbers that can't be written as a fraction, so they're decimals that go on forever. So like pi, e, the square root of 2, etc. Okay? And then rational zeros are those that can be written in the form of a fraction, so p over q. Okay? So the rational zeros theorem can be used to determine all possible rational zeros of a polynomial function. So to do this, you do p over q. P is always the factors of the constant term. So that is a sub 0, or this is the last term. And then q is the factors of the leading coefficient, so a sub n, or the first term. So this is the factors of the last term over the factors of the first term. Okay? So here we're just going to list all the possible rational zeros. So here a sub 0 is -2 and a sub n is 1 because that last number there is -2, so that's where we got that. And then a sub n, there's no number there, so it's just 1. So then the factors of 2, that means p equals 2 and q equals 1. Well, the factors of 2 are plus or minus 1 and plus or minus 2. It will always be plus or minus. And then the factors of q are plus or minus 1. Now, if that's a 1 on the bottom, that's the same as just doing plus or minus 1 or plus or minus 2. Okay? Let's look at this one. So now we have x to the 5th plus 9x cubed minus 2x squared minus 18. So that means a sub 0 is -18 and a sub n is 1. So p is 18, q is 1. So the factors of 18 are 1, 2, 3, 6, 9, and 18. If you struggle writing out factors, just write them out this way. So if we have 18, we know 1 and 18. I'm going to write it over here actually. So we have 18. We know 1 and 18. 2 goes into it 9 times. 3 goes into it 6 times. 4 doesn't go into it, and 5 doesn't go into it, but then we got 6, so we're good. So our factors here are 1, 2, 3, 4, 5 doesn't go in, 6, 9, 18. Cool? And then it's over 1, so then this ends up being plus or minus 1, plus or minus 2, 3, 6, 9, and 18. Those are possible zeros, and I'll get to what we're going to do with those zeros in a second. Now here we have 4x cubed minus 4x squared minus x plus 1. So a sub 0 equals 1, a sub n equals 4. So that's going to be p equals 1, q equals 4. So the factors of p are 1. The factors of 4, which is q, is 1, 2, and 4. So now to write this out, we're going to have 1 because we write the 1 over 1. So we do this part. And then we have 1 over 2. Then 1 over 4. And they're always plus or minus. Okay, this last one, 16 and 3. So that's going to be plus or minus 1, 2, 4, 8, and 16 if you write the factors of 16. The factors of 3 are just 1 and 3. So from the 1, if we divide all those by 1, you're just going to get 1, 2, 4, 8, and 16. Now if we divide them by 3, we're going to get 1/3, 2/3, 4/3, 8/3, and 16/3. Okay? You try to do E and F. So let's look at this one. So we want to list all the possible rational zeros, test the zero using synthetic division, and then when you find a zero that works, use the remainder to completely factor the blah, blah, blah. Okay, so first we need to find the possible zeros. So we're going to do the P over the Q thing, what we were just doing. So we have P equals 8 and Q equals 1. So that's going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8 over 1. So that's just 1, 2, 4, and 8. Now we have to test these and see when they work. To do this, an easier way to do this is to just plug it in. If you get 0, then it is a factor. If you don't get 0, then it's not a factor. So let's start by plugging 1 in. So we plug 1 in for the x, and you get negative 10. So that one doesn't work. Let's try negative 1 now. When you plug that in, you get 0. That's good, and that means that x plus 1 is a factor. And, wait. I want to go back. So this means that we have a 0 of x equals negative 1. Because we plugged negative 1 in and we got 0. So there's a 0 at negative 1. To write this in factored form, I'm just going to add the 1 over. So you get x plus 1 equals 0. That's where this factor comes from. Okay? So now, once you find one factor, you have to do synthetic division with it. So then this is going to be 1, 3, 6, negative 6, and negative 8. And negative 1 goes on the outside. So synthetic division, drop the 1 down. 1 times negative 1 is negative 1. 3 minus 1 is 2. 2 times negative 1 is negative 2. Negative 6 minus 2 is negative 8. Times that, you get 8, which is 0. So we have x squared plus 2x minus 8. Now we need to factor that to find the rest of the zeros. That factors to x plus 4 and x minus 2 if you use the x to factor that, because you're trying to see what multiplies to be negative 8 adds to be 2. Well, that's 4 and negative 2. And then we can set those equal to 0. Well, we can write it out completely factored, so we get the x plus 1 from this, and then the rest of these come from there. Then we set all of them equal to 0. So that's going to be x plus 1 equals 0, x plus 4 equals 0, x minus 2 equals 0. So x equals negative 1, negative 4, and positive 2. Okay? Let's look at this one. So we have 18 and 1. So P is 18, Q is 1. So we're going to find all the factors of P over Q. And you get 1, 2, 3, 6, 9, and 18. Because the factors of 18 are 1 and 18, 2 and 9, 3 and 6. The factors of 1 are just 1. And then we're going to plug them in. So if we plug in 1, you get negative 54. So it doesn't work. And when you plug it in, just put the whole thing in your calculator. When you plug in negative 1, you get 0. So negative 1 works, which means x plus 1 is a factor. So now we're going to use synthetic division. So we have negative 1, and then 1, 3, negative 7, negative 27, negative 18. Bring down the 1. 1 times negative 1 is negative 1. Negative 1 minus, or 3 minus 1 is 2. 2 times negative 1 is negative 9. Negative 7 minus 2 is negative 9. Times that, you get 9, negative 18, 18, 0. So this factors to x cubed plus 2x squared minus 9x minus 18. We can still factor this, you just have to factor by grouping. So that's going to be x squared, x plus 1, minus 9, x plus 1. So you get x plus 1, x squared minus 9, which that x squared minus 9 factors to x minus 3 and x plus 3. I told you factoring wasn't going away. I was never lying about this. You need to get factoring down as soon as possible. Okay, if you're struggling with factoring, you have to come in and get help. Okay, if you got lost in what I just did, that is a sure sign that you need to come get help. Now we can set that, put it all together. So we have the x plus 1 from right here, and then this from right there. So this can be written, since we have two x plus 1s, it can be written as x plus 1 squared, and then x minus 3 and x plus 3. So it's x plus 1 equals 0, x minus 3 equals 0, x plus 3 equals 0. So x equals negative 1, x equals 3, and x equals negative 3. Okay, this one we need to find all zeros and write it in simplest form. So we have x to the 4th minus 9x squared plus 18. Well, if this was x squared minus 9x plus 18, we would know how to factor this. We would just factor it by x minus 3, x plus minus 6. We can do the same exact thing over here, except now we're breaking up this x to the 4th into the 2x squareds. Whereas here we broke up x squareds into just those x's. So we have x squared minus 3 and x squared minus 6. We're finding the zeros, so we can set those equal to 0. So we get x squared equals 3, square root it, and you get x equals plus or minus the square root of 3. Whenever you do a square root, you have to do the plus or minus if there's an equal sign. Here we're adding the 6 over, square root both sides, so x equals plus or minus square root of 6. Okay, you do example B, you should get that. Let's try this one. So this one, always try factoring it first. Okay, the rational roots theorem, so what we did in the past couple of slides, that will always work, but factoring is easier. Okay, if you can factor it, factor it. So in this one, we can take out an x squared and you're left with 2x plus 5. Take out a negative 12, you're left with 2x plus 5. So you get x squared minus 12 and 2x plus 5. Set those equal to 0. Here we're adding the 12 over square root. So you get plus or minus the square root of 12, which you can break down the square root of 12 to 2 square roots of 3. Here we're going to subtract the 5, divide by 2. So we get x equals plus or minus 2 square roots of 3. So there's two answers here. You need to be aware of that. So that's 2 square roots of 3 and negative 2 square roots of 3. And then negative 5 halves. Okay? You can't have a square root in the denominator, blah, blah, blah. So list all possible rational zeros and then find the real zeros. Try factoring before you use the rational roots theorem. So it says to list the possible rational zeros, and I didn't do that. So let's just list them. So it's P over Q, which here my P is 36 and my Q is 1. So my factors are going to be plus or minus 1 and plus or minus 36. 2 goes into it 18 times. 3 goes in 12 times. 4 goes in 9 times. 5 doesn't, and then 6 does. So it's 1, 2, 3, 4, 6, 9, 12, 18, 36. That's all over 1. So these are the possible rational zeros. And then here we can factor this. So there's 4 terms, which means we're going to factor by grouping. You can take out an x squared there and you're left with x minus 2. You can take out an 18 there and you're left with x minus 2. So you get x squared minus 18 times x minus 2. So set them equal to 0. X squared minus 18 equals 0. X minus 2 equals 0. Add the 18, square root, so you get, when you break down 18, that's 2 times 9, which is 3 times 3. So that's where this 3 square roots of 2 comes from. This one, we just add the 2 over, and you get x equals 2. Okay, save those last two. Remember to take the quiz. Thank you. Goodbye.